We are honored to present our work entitled FairCLIP, Harnessing Fairness in Vision Language Learning. This research is a collaborative effort between Harvard University and New York University. There are three key motivations behind our work. Firstly, fairness is a critical concern in deep learning for healthcare, as these models influence diagnosis and treatment decisions. Ensuring equitable outcomes across diverse patient populations is essential. Secondly, multimodal data is pivotal in enabling both humans and AI models to understand eye diseases from the multiple perspectives. Its increasing prevalence highlights its significance in disease diagnosis. Lastly, the impact of the vision language data, a prevalent and vital form of multimodality on training AI models for glaucoma detection, has not been fully explored. Addressing this gap is crucial for advancing diagnostic accuracy and fairness in healthcare AI. Existing fairness datasets such as Jasper and Mimic CXR have advanced the field of fairness research by pairing images with the radiology reports. However, they fall short in providing extensive demographic data and are prone to noisy labels due to their automated labeling process. Moreover, these datasets were not initially created with a focus on fairness, which limits their utility in studying fairness comprehensively. To address these challenges, we introduced our FairVL dataset. This dataset ensures high label quality and includes a broad range of identity attributes such as age, gender, race, ethnicity, and preferred language. By providing detailed demographic information and maintaining high data quality, FairVL facilitates more rigorous and comprehensive studies on fairness in healthcare AI. The average age of the patients is 60.9 years. The dataset constitutes 8.2% Asian patients, 14.9% Black patients, and 76.9% white patients. There are 56.3% females and 43.7% males. Regarding ethnicity, 90.6% patients are non-Hispanic and 4% are Hispanic, and the rest has unspecified ethnicity. In terms of the language preference, 92.5% patients prefer English, 1.7% prefer Spanish, and 0.8% prefer other languages. To intuitively understand the data in FairVL, we show two examples of clinical notes, one for non-glaucoma patient and the other one for patient with glaucoma, along with their corresponding SL fundus images. It's worth noting that doctors often use uncertain or ambiguous phrases like suspected disc damage to ensure rigor and accuracy in their diagnosis. Investigating how this uncertainty and ambiguity affect fairness in vision language learning has a significant medical implications. CLIP, short for Contrastive Language Image Pre-training, was developed by OpenAI and has become the mainstream model for handling vision language modalities. However, it's insensitive to equity considerations. In order to improve the fairness of the vision language models for glaucoma diagnosis, we introduced FairCLIP specifically after undergoing the identification and the text summarization. The semantics of text are aligned with the semantics of image during pre-training. Moreover, FairCLIP minimizes the distribution distance between the mixed group and the demographic groups in vision and language alignment. The primary objective of FairCLIP is to minimize disparities between demographic groups by equalizing the probability distributions of the correlation between the visual and language features across these groups. To achieve this, FairCLIP employs the single-home distance variant of the versatile distance to measure and minimize the distance between the overall distribution and each group specific distribution. We divide 10,000 patients into three subsets: 7,000 patients for trainings, 1,000 patients for validation, and 2,000 patients for testing. We evaluate the equity of the AI models in glaucoma diagnosis in two settings: zero-shot transfer and end-to-end fine-tuning. In the zero-shot transfer, we can see notable performance gap between the demographic groups on both CLIP and FairCLIP. For example, the black and white, the female and male, the non-Hispanic and Hispanic. Another observation is that the proposed FairCLIP improves the performance on the underrepresented groups. For instance, 2% improvement on the black group, 2% improvement on fair group, 3% improvement on the Hispanic group. In the end-to-end fine-tuning, we train the AI models with the SL fundus images, clinical notes, and the diagnostic labels. Besides, to understand the contributions of each modality to disease diagnosis, we take text encoder and vision encoder into account of comparison as well. We can see that using text alone for training lead to a lower performance across the various demographic groups. Using SR fundus images with or without clinical notes result in better performance than using clinical notes alone. This implies that the medical imaging data is informative in glaucoma diagnosis. Moreover, the proposed FairCLIP overall achieves the better performance on the underrepresented demographic groups. Also, CLIP exhibits the notable disparities across the other matrices, including demographic parity difference, DPD for shot difference in equalized odds, DE odds for shot, overall AUC, and the equity scale AUC, ES AUC for shot, indicating the presence of the bias in glaucoma detection. In most cases, FairCLIP improves performance across the measures DPD, DE odds, overall AUC, and the ESAUC in both the zero-shot transfer and end-to-end fine-tuning settings. In conclusion, the equity in glaucoma detection using either text or imaging inputs alone remains consistent with the equity achieved when using both modalities together. Utilizing the clinical notes alone will lead to a low accuracy in glaucoma detection. Combining clinical notes with the SL fundus photos yield better performance compared to using clinical notes alone or SL fundus photos alone. Our proposed method FairCLIP facilitates vision and language alignment and demonstrates the promising performance improvements in enhancing fairness for downstream tasks. Thank you for your attention and engagement.